Hi. So we're going to do some quick slides for context, and then we're going to go into some fun demos. So there's a lot of things you could talk about when building MCP servers, but I was thinking about the questions we've been fielding and thinking about what's new, and really this venture into how do I build a remote one, and then what are some of the things that are different that I should think about is sort of like top of mind for a lot of folks and for us at Microsoft. So I'm going to talk about that. Who am I? I'm Caitie McCaffrey. I am a software engineer at Core AI, which is a division of Microsoft that builds AI platform. So we build Foundry, we build the Azure OpenAI endpoints. We also have GitHub, VS Code, all of our coding agents, all in like one organization. And I've been technically leading our MCP efforts across Core AI and the company. And so I just wanted to give you, when we talk about thinking about Model Context Protocol at Microsoft, and we're very excited about it because we're seeing a ton of developer traction, and it's helping unlock a lot of great scenarios, is we think about it in these different frameworks, right? We have our clients and hosts, so we have things like Copilot Studio, which help you build low-code, no-code agents for business process automation. We have VS Code and GitHub and Visual Studio for all the developer scenarios. We have things like Foundry agents for more of a pro-code way of building, like autonomous agents that run in the cloud. And all of these things now support MCP, so we're really supporting this across the breadth of our portfolio. We're launching a lot of tools. I think you just heard about Playwright's a really popular one. The GitHub Remote MCP Server is one of the most popular remote MCP servers from the data we have, and a lot more are coming. We have a bunch of local and a handful of remote that we've been experimenting with. We've also been focused on how can we help the community find all of these tools, right? I think it started out as an ecosystem where you would go to like awesome MCP servers list, github.com. And so we've been working with Anthropic, which has defined a standard for how you like publish data about an MCP server. They have the OSS community registry, which is in beta. We also launched the GitHub registry, which is in August. And so you can go there and find local and remote MCP servers with click button install into VS Code, Visual Studio, and a bunch of other things. If you are running MCP servers just for your organization and you want to have a local registry, we also have a solution for that using API Center. And then we're also bringing MCP to Windows devices so that you can manage them. And this is more of an enterprise scenario of like, your IT might not want you to install like MCP server from some malware company or whatever, right? Or we can use our security tools to help you find when they've been popped and things like that, just like one of a popular package on Node was recently. We're also building a lot of tools to help you build MCP servers. So we have the C# SDK, which we build. We have Azure API Manager, which helps you turn open API specs into MCP servers and logic apps and other things so that you can take all your existing tools and make them agentic or available to agents. We also provide functions, containers, all of that goodness. And then we've been partnering really closely with Anthropic and the OSS community to evolve the protocol, right? So like notably, we're very involved in adding the authentication spec and improving it. We're working with them now on the latest protocol rev that's going to happen. Okay. Real quick, I want to talk about the lessons learned today. I'm going to talk about from a couple things that we've been building and shipping internally. Notably, we have a couple popular remote MCP servers that have enough traction that I can say reasonably, I can talk about their operational characteristics. I can give you like meaningful lessons learned versus like I hacked this together in a weekend and like launched it and prayed. So we have the Learn server, which is our docs repository. And so you can go and like have an MCP server that asks for best practices on how you're doing something. I use this a lot with GitHub Copilot. It's like, how do I do this thing in Azure? Or build me a website in Azure, it'll go pull the docs and then leverage that plus the Azure SDK, and I can get a website up and running really fast. We have the GitHub MCP server. I'm assuming most of you have used that. That's super fun and popular for interacting with GitHub. And then Foundry to help you build agents. And then once again, we have a bunch of hosts that are launching this. VS Code and Visual Studio are running like on your laptop in a constrained environment with one user, but we're also exploring how we can build autonomous agents that run in the cloud, and they're only going to really use remote MCP servers. You could go through the rigmarole of installing a local one and popping it up behind an API endpoint, but like the future for autonomous agents is sort of these remote endpoints, and so that's Copilot Studio and Foundry. So when you're talking about remote MCP servers, you're going to be using the HTTP streamable transport. So this is, you have your MCP client. It's talking to the server via a combination of HTTP post messages. It's still using JSON RPC, and then you optionally can create an SSE channel as a durable connection from your server to your client for server sent events. So why might you want to do this optional SSE channel? It is optional and it is totally spec compliant not to provide it. The things highlighted here in purple require optional require server sent events. So right now that means you need some kind of SSE channel, or you're gonna do something weird like piggyback it onto a post request, which I wouldn't recommend. It's hard for the clients to deal with that. So if you're having tools, prompts, or resources and you wanna like update them mid-connection, then you need a server sent event. If your server is gonna leverage more advanced MCP features like sampling, elicitation, or routes, then you also need to have server sent events. So that's enough talking. I'm gonna jump in and show you how I build some of these using some dev tools that we have internally, but the lessons apply. So this is, Aspire is like a framework for building services that is opinionated. It currently only supports .NET, but we are expanding it to support, to be polyglot, and we're focusing on Python and TypeScript and all of that. That was just officially announced yesterday. But what I like it is it makes it really easy to like bootstrap your service, get everything up and running, define defaults, things like that. So this is my project. The first two are just Aspire defaults. Don't worry about that. If you care about Aspire, talk to me later. I have my, Pet Store API service, if you look at this. So this is like, we just offer a Pet Store API. This is our demo API service. But think of this as like, hey, I have an API, and instead of just putting like a weird MCP head on it, I actually want to build an MCP service that calls it, that's remote. And so I would recommend, and then I have this set up where I have a Pet Store MCP service. So I deploy it as a separate service, and I think that's a good thing to do as we're all learning from an operational characteristic perspective. And that's how we're doing it at Microsoft, where you deploy these things separately, and then they forward calls to the API service. So I'll show you what that code looks like really fast, and then we'll dig into like what does this look like when it's running. So this is the MCP service. This is the C# SDK. You know, a lot of the SDKs look the same. You can annotate your code. You can define tools, and then I'm mostly just forwarding requests to the API. Okay, so let's run this. So what's happening here is Aspire is gonna run my project, and it's actually gonna launch everything in a really nice local development environment. If you don't wanna use Aspire, that's fine, but I think you can look and see what is interesting and what this is a quick way for me to show you the stats that I look at when running this. So Aspire launches a local dashboard. You can see my API service and my MCP service are up and running, and it has a bunch of metrics we can get into. But let's test our service now that it's running. I'm gonna launch MCP Inspector. I think most of you may have heard of this tool. It's part of the open source project. It helps you easily test your MCP services remote or locally. Let's do that, and let's run these side by side so you can see it. Okay, so you can tell I've been testing, but if I didn't know the endpoint it came up at, my MCP service is here. And so we can connect, and if you've used MCP Inspector before, you can see that the initialization handshake, that's part of the protocol that's happening. I like to highlight this because this is hidden by most of the SDKs, but I think it's important to understand it from the operational characteristics of your service. It's also setting log levels. We can do things like list tool, and I can even call my get pets API. And then I can disconnect and all of that niceness. So what just happened there, right? My service seems to be working, but let's dig in and understand like what did the protocol actually do? So for Aspire, I really like because you can like see all of this in one-stop shop as a developer where I can look at my logs for my services, I can look at structured logs, but traces are where I think it's really, really helpful for shipping remote MCP services. So the C# SDK supports full OTel. I think most of the MCP SDKs support OTel at this point, and so you can actually stitch together and see what's going on. So let's take a look, right? So it did the initialization call, which you can see happened here. It is then going to do a 3-part handshake between the server and the client. So this is the third part from the client saying, yep, we're done initializing. And then it's gonna set the log level. And these are all messages from the client. It's also gonna do this GET request. And so that's opening the optional SSE connection. And as you can see, it's long running. This lasted for 16 seconds, essentially until I disconnected the server. And we'll come back and talk more about that. And then you can also see things like I did tool list, and I did my post to get pets, and that's what it returned, and I can actually see all the hops that happened on the service. And so this is just really useful. I would highly recommend setting up OTel as you're setting up your remote MCP servers. It's really great for debugging when things don't work. Okay, so I want to pop back to this initialize call and this SSE channel. Because as you know, notice here in the server notifications, my service isn't using any of the notification features. It's just doing straight get, like, request response calls to my API. I'm not gonna update anything, I'm not doing anything fancy, and like a lot of the MCP servers we're seeing out there that are really popular and are making our agents really powerful don't require this right now, and that's totally fine. But I did establish this SSE connection. So let's take a look at like what does this mean for my service. So the other thing I like here is I can go look at all of my metrics, and we can go look at, request duration that happened from me just clicking around in the UI. You can see all of the different calls if you wanted to drill in. But you can also see that there's this active request. And if I reconnect, you'll see that another active request happens and is persisted, and it will continue until I disconnect the client. So as a server developer, I don't trust clients because they have screwed me over too many times, even when they're on your team. You should assume they are going to do the worst behavior possible, even if the spec says they shouldn't. And so I like to know how the client is behaving so that I can make sure my service is reliable. And so I think it's really important to understand what's happening here with these SSE connections. They are established, they are pretty long running for the protocol. You can disconnect and resume them, although that logic is tricky and some of the clients are still working out how to handle that correctly. And so you can't see much of what's actually happening here in MCP Inspector, and so I wrote a little script, or Copilot and I wrote a little script this weekend to walk you through what's actually going on. You guys see that? Yeah. Okay, so this is mimicking a client, and it's saying, connect to the server, and this is what it sends, the JSON and the headers. And I think the headers are interesting to look at as well, which maybe MCP Inspector will show eventually, particularly for remote, because there's interesting information in there. And then the server responds here. And if you notice, there's an MCP session ID. And so this is part of the protocol, and it's often on by default in most of your SDKs. And when your server returns this to a client, what it's saying is that I think this session is stateful. I assume that when your MCP server is making calls back and forth to me, that I need to persist some state on my side because there might be multiple interactions happening. But if you're just wrapping an API that already exists, that's probably not what's happening. And so you may not want to return this because it's telling the client to do something you probably don't want it to do, and it's asking the client to hold on to a bunch of state. And then as we go through, you can actually see what's happening as part of the initialization event is it's not returning a JSON blob, it is returning an SSE event. So a lot of the servers in the SDKs will open an SSE channel as part of the initialization request, and then the client may or may not close that. And then the server finishes its handshake. And what my client here is doing is now it's also establishing an additional SSE stream. So what does this look like on my server? Okay, so now I have two clients connected, and I have two persistent connections, and they're just hanging out and they're not doing anything. This is, once again, if you want to use those features, this doesn't apply here, but I haven't seen as much experimentation in this space of sampling and elicitation, because I just think they're new and we're still learning how to use them. So they're not the bulk of the use cases. Okay. So I probably don't want this on because it's going to consume resources on my server, and it's going to make scaling it harder. And then I'm also essentially telling the client it has to do a bunch of tricky logic to reconnect and disconnect when the server breaks or when the connection breaks. So how do we fix that? Once again, every SDK is somewhat different. But in the C# one, when you declare your server and that you're using the HTTP transport, there's a couple options that you can set that I think most of the SDKs support. So you go, and I'm going to say that I know my server is stateless because I'm just doing straight up API request response. I don't need you to persist anything between. And I'm also going to say that I don't want any of the connections just hanging out, right? If I know all my tools that I'm offering are short running, they should respond within milliseconds. And so if the client's going to hang on to a connection for a long period of time, I don't want to do that. So I'm just going to forcibly close it. And this protects me from a client that's kind of maybe doing some bad behavior or has a bug in its code or whatever, right? Things are evolving really quickly. Okay, so this is super easy now. And I just want to show you what that looks like when we'll kill this session, run that. Let's make sure saved. Let's try that again. Apologies. there it goes. I don't know what it picked up. So yeah, the host endpoint for Aspire, if you're using it, often launches on the same port, so you can just refresh the page. So you can see my new servers are now up and running. And I'm going to go back, and we're going to run our little script, and I'm going to show you what's changed. You can't see the headers in MCP Inspector, so that's why I have this. You can see I'm no longer sending the session ID, and so that's just a clue to the client that like this is not a stateful session. And then I'm actually refusing calls to 404 or to establish the SSE stream. I'm saying this is not allowed. This is actually what the spec tells you to do. This is spec compliant. This is actually what all of our remote servers currently do today because we're not using any of this functionality yet. When we do, then we'll start talking more about like there's a lot of things to take into consideration when you're shipping stateful services that like have to maintain persistent connections, and then you have to do routing and blah, blah, blah. But this is like totally fine, and I think something worth looking at today. And so then I'll just show you really quick that now our service is answering requests and not maintaining persistent connections. And that makes me much happier if I'm wearing the pager at night. So, so that's all I have for you today. If you have any questions about remote MCP servers, local MCP servers, or like how to build them or anything we're doing at Microsoft, I'm happy to chat. Thanks.